All right, welcome back. Let's do an example of a Riemann sum. So here we go. Let's calculate the Riemann sum. R for the function f of x equals x squared. The partition interval I should give first. Let's do, what did I have? All right, 1 to 2. Partition. So you have to start with 1 and it has to be bigger. That. I suppose I should put less thans here. Okay. What else do we need to specify? And sample size, or sample points rather. So C1 equal to 1.2, C2 equal to 1.4, C3 equal to 1.7, and C4 equal to 1.9. So you should really have in your mind a picture here. You're going from 1 to 1.3 to 1.5 to 1.8 all the way to 2. These are your x's, x0, x1, x2, etc. all the way x1, x2, x3, x4, so that'll be x4. And then you have your delta x's, so delta x1 will be the difference here, so 0.3. Delta x2 will be 0.2. Delta x3 will be 0.3, and delta x2 will be 0.2. And then you have the c's in here. So C1 was 1.2, C2 was 1.4, C3 was 1.7, and C4 was 1.9. And remember, the Riemann sum uses these points plugged into F to get the height of the rectangle. But anyway, here's the definition. It approximates the area under the curve. The definition is it's the sum from j equals 1 up to 4, that's what n is here, of f of cj times delta xj. So the long form, remember, is just f of c1 delta x1 plus f of c2 delta x2 and so forth. And we just plug in. The function is the square, so c1 was 1.2, square it. The delta x is the 0.3. F of c2, that's 1.4 squared. The delta x is 0.2. The next c is 1.7 squared. The delta x there was 0.3. And then the last one was 1.9. Delta x was 0.2. And that's it. Again, you can put this on a calculator, do it by hand, whatever, but that's the Riemann sum. That's all. Ciao.